This type of questions are called nested radicals. Okay, all right, so we are going to have the square root of, now the square root of 9 is 3 minus, now 8 is the same as 4 times 2. All right, from sets, if you have the square root of a times b, this gives us the square root of a times the square root of b. All right, so you're going to have the square root of 3. Okay, we're going to have the square root of 3 minus the square root of 4 times the square root of 2. All right, so this gives us the square root of 3 minus, and the square root of 4 is 2. Okay, so this is what we have. So we are going to have the square root of 3 minus 2 root 2. All right, so 3 is the same as 2 plus 1. So our equation becomes 2 plus 1 minus 2 root 2. Okay, minus 2 root 2. All right, so you're going to have the square root of, okay, 2 minus 2 root 2 plus 1. Now, let's quote the square of a binomial property and do some comparisons here, okay? So a minus b all squared should give us a squared minus 2ab plus b squared. All right, so let's change the positions of the terms. Okay, so we can say a squared minus 2ab plus b squared equals a minus b all squared. Now, so when you look at this, okay, you can see this is the first part, this is the last part, and this is the middle part. Okay, so when you compare, you can compare this to what we have. So this part, this is the first part. Okay, so let's do the comparison. All right, so this stands for the first part, this stands for the middle part, this stands for the last part. All right. All right, so you're going to say, okay, now we want to know the actual number that was squared to give this 2, which stands for the first part. And then we want to know the actual number that was squared to give this 1. Do you get me? Which is the last number. Okay. All right. Now remember, the first part stands for the a squared. The second part stands for the b squared. Sorry, the last part stands for the b squared. So we say, okay, let's represent the first part by a. So a certain number squared gave us 2. Okay, this stands for the first part. And then let's represent the last part by b. So a certain number squared gave us 1. All right. So we are going to say a squared equals 2. So let's multiply here by half and here by half. So now we have a equals 2 exponent half. So that's equal to the square root. Okay, we can say a equals the square root of 2. Okay, and then we can say, so you've had a. Now let's solve for b. Okay, so you're going to have, okay, b squared equals 1. Let's multiply here by half and here by half. Okay, so you're going to have b equals, okay, 1 exponent half. Okay, and that's the same as b equals the square root of 1. All right, so we are going to have, okay, so we know the first part, okay, let's say now we know a equals the square root of 2 and b equals the square root of 1. Okay, now we stated that a minus b squared is the same as, okay, a squared minus 2ab plus b squared. Okay, so this part stands for this. All right, now if we have used a and b to represent the first part and the last part of our equation of our question respectively. Therefore, we can say that root 2, okay, we can do the substitution. Okay, so our question is going to be, okay, root 2 minus root 1 all squared. Okay, all right, now remember we are having square roots, so we say the square root of root, okay, 2 minus root 1 all squared. All right, so this square will cancel this square. So you have root 2 minus root 1, and root 1 is 1. Okay, so this is our final answer. So you're going to have the square root of 2 minus the square root of 1.